What is going on, everyone, and welcome to the Fusion 360 tutorial series. This is day 1 of learning Fusion 360 in 7 days. This tutorial series is for complete beginners with Fusion 360 in order to learn the ropes from sketching our first component to assembling geometries by day 7. Today we will be taking those first few steps. We will start by familiarizing ourselves with the user interface, creating a new project, and then dive into the basic sketching techniques, looking at how to create our first lines and rectangles. By the end of this lesson, we will take a look at the extrude command to turn the sketch we've created into a 3D object and learn how to cut away undesired material in order to turn the box we have created into a brick. Let's get started. First, let's take a look at the Fusion 360 user interface. When you open Fusion 360, you'll see several key areas. First is the toolbar, located at the top. This is where you'll find tools for creating sketches, modifying 3D models, and creating assemblies, and much more. There are different tabs located at the top which provide these functionalities for different types of bodies, such as solid bodies, surface bodies, mesh bodies, sheet metal, etc. And finally, as seen by the first giant box on the toolbar, there are different modes we can set Fusion 360 to in order to have different functionalities, such as design work, creating, rendering, and animations and simulations. But for the purpose of this series, we will mostly stay in the design section. The second key area of the user interface is the browser on the left side. This displays your project structure, including the document settings, as well as the sketches, bodies, and components, which will appear once they are created. If we press on the triangle beside document settings, we can see the units that our environment is set in. If you wanted to change the units, just hover over the Units tab and press on the paper and pencil icon that appears. This will open up this window here. And we can change the units with this drop-down menu. Don't forget to press OK to confirm the changes. But for this tutorial, we'll keep the units to millimeters. The third key area is the canvas, the area in the middle of the screen. This is the main area where you will be creating and viewing your designs. The fourth key area is the navigation bar located at the bottom. This will help navigate around your models with the tools like pen, zoom, and orbit. Typically, we will use keyboard shortcuts for these navigation functions, which will be mentioned as they are used. There is also the project timeline. As we use different features, they will appear in a timeline fashion at the bottom bar here. And we will be able to quickly suppress features if modifications should be made earlier in our design. I encourage you to pause the video now to take a moment to explore these areas and get comfortable with their layouts. And finally, if we press on the 9 square grid at the top left-hand corner, this will open up the Project tab. Since Fusion 360 is a cloud-based software, all of your designs can be neatly stored into different projects. Different projects also allows you to share it with your friends or colleagues so that they can also collaborate on the designs and projects with you. So let's go ahead and create a new project for learning Fusion 360 in 7 days. Press on New Project, and let's name it Fusion 360 in 7 days tutorial. Double-click the project to open the folder. By pressing on the People's tab, this is where you can add collaborators to your project simply by sending them an invite to their email that is linked to their Fusion 360 account. We can also add new folders within each project. So by using the New Folder button, we can create a new folder and call it Day 1. Now with our project folder created for Day 1, we can move on to creating our first object, the brick. To start, it is good practice to create a new component each time you want to start a new part. To do this, we will press on the New Component button in the Assembly section of the toolbar. This window will appear here. The type of component will always be a standard component unless it is sheet metal, which are different in how they are designed and manufactured. Therefore, for our brick, we will choose a standard component and we will name the component here. Press on OK to create the part, and we can see now that our component has shown up in the browser. Now we will start with the first sketch. We're going to go ahead and press on the Create Sketch button, which looks like a line and dots with a green plus. Press on it, and we can see a coordinate origin appear in the middle of the screen with 3 yellow planes. This is Fusion 360's way of promoting you to choose a plane you would like to make your sketch on. From the little navigation cube, we can see that the red axis signifies the x-axis, the green axis signifies the y-axis, and the blue line signifies the z-axis. So let's go ahead and choose the XZ plane as our sketching plane. This is considered to be the top or bottom plane in Fusion if we look at our navigation cube. So sketching on this plane will allow us to better orientate our object within the environment. So I'm going to go ahead and choose that plane by pressing on the yellow square, and we can see that the environment turns parallel to that plane for easier viewing. Now we need to sketch the base shape of a brick, a rectangle, and there are multiple ways that we can do this, and I will go over a few of those choices. The first command that we can choose is the line command, which is the first icon in the create section of the toolbar. Press on that. When I don't move my cursor, we can see that it says to place the first point. So I will place that first point on the origin of my environment, which is denoted by the circular icon. I will then drag my mouse out to start forming a line. To create the line, we can either click where we want our line to finish, or we can specify the dimensions of the line by typing the length and the angle into the dimensioning boxes. So let's type 150 millimeters, then press tab on our keyboards. We can see that the highlighted dimensioning box has changed to the angle dimension, and if we move our mouse, our line is locked at 150 millimeters. Now we can specify which angle we want our line to be at. I'm going to put 0 and press on Enter on my keyboard. Now we have drawn a line of 150 millimeters along the x-axis in our environment. Let's go ahead and add the 3 remaining lines. Press on the line command and choose the point where we want to start a line. If there is a blue box that appears around the cursor, this is indicating that we are starting your line at the end point of another line. If you drag the cursor along the line, you can see that the blue square changes to a blue X, indicating that you are starting your line somewhere along this other line. And if the blue triangle appears, this indicates that you are starting your line at the midpoint of another line. So for our next line, let's go ahead and choose an endpoint and drag the line out. Like before, we have 2 dimensions, the length and the angle. If we drag the line out closer to 90 degrees or perpendicular to the other line we are sketching off of, Fusion will actually softly snap to 90 degrees, which is denoted by the blue perpendicularity box that appears between the 2 lines. So, with our line perpendicular to the other, let's enter the dimension of 75 millimeters, and if we were to press Enter, this would create the line and terminate the line command. However, we have more lines to draw. So if we simply left-click our mouse after putting in the dimension of the line, we can see that the line gets created, but the line command stays active, so we can continue creating other lines. However, note that the new line will always start from the endpoint of the last line created. In this case, that is where we would want to have our next line started. So let's drag the third line out, making it perpendicular to the last line we drew. And if we go far enough, we can see that the program will actually softly snap to a location and show us a dotted blue line that goes down to the endpoint of the line that is parallel with it. This indicates that these lines will be of the same length. So let's left click at this location to create the third line, and then we can drag a line perpendicularly downwards to create our rectangle shape. Upon the creation of this closed shape, we can see that Fusion terminates the line command and highlights the surface of the closed shape in blue. If the color inside your shape does not turn blue, it means that your sketch is not properly closed, and you won't be able to turn it into a 3D shape later on. So just keep that in mind. The next thing that we're going to want to do is to ensure that our sketch is fully defined. This ensures that the geometry is completely restrained within the environment to prevent it from moving unintentionally when we use other commands. This is particularly important for parametric design, enhancing the accuracy and stability of the model and sketches. We will talk about parametric design in a later video. A fully defined sketch in Fusion is shown when the sketch lines turn black instead of the blue color. In this case, we can see that the sketch is fully defined because all the sketch lines have turned black. So we can go ahead and actually turn this sketch into a 3D object. But in the future, when we do have a sketch that's underdefined, that will be denoted by the blue lines, I'll make sure to show you guys how to make it fully defined using the dimensioning tool. So stay tuned for that. Now that we have a fully defined sketch, let's go and turn it into a 3D object. First, we are going to exit sketch mode by pressing on the big green check mark that says Finish Sketch. And we will press the Extrude command, which is the second command here that looks like a box. When we do so, this window will appear here. The type is going to be a regular extrude. For profiles, we are going to select the surface we created. For the start of the extrude, generally you will want to choose the profile plane since it will extrude from the sketch, but there are other options that we can select, such as offset, which will start the extrude from some specified distance away from the created sketch, and object, which will extrude the sketch starting from a selected object face. But generally, you would want to use profile plane. For direction, again, there's three options. We have one-sided, meaning that the extrude will happen in one direction from the sketch. There's two-sided, meaning that the extrude will happen in two directions from the sketch, and they do not have to be of equal length. And we have symmetric, meaning that the extrude will happen in two directions from the sketch, and both of which will be of equal length. For how long we want our extrude to be, there are a couple ways we can specify this. Through a distance, which can be determined by dragging the arrow on the screen or typing the dimension we want in the dimensioning box. To an object, which will prompt us to choose a surface, and the sketch will be extruded flat to that surface. Or all, which is more useful from cutting away materials, but this will simply perform the command through the entire object if we already had a solid. We will explore these capabilities more in just a few seconds, but for now, let's just choose distance extend type and specify our distance to be 50 millimeters. We also have the option of adding a taper, which will decrease the cross-sectional area over the height which we extrude our sketch. And this is specified by specifying the taper angle. However, for this scenario, we just want our object to be a box with zero taper, so I will leave the taper angle as 0 for now. And finally, operation type specifies how we want Fusion to handle the new 3D object. There are several commands, but the two most common ones are join, which will join the created body to an existing body, or cut, which will cut away the extruded body from an existing solid. In this case, we are going to choose the operation type as join to join the 3D body to the existing components in the environment. Press on OK to confirm the extrude command, and there you have it, a 3D solid block based on the sketch we originally created. Very cool. Now, I'm going to have to let you guys in on a secret. There's a much easier way we could have created that initial rectangular sketch. Now, let's go back to the sketching menu on a new environment. Press on the sketching icon and choose the plane you want to sketch on. Now, if you notice in the Create section of the sketching toolbar, right beside the line command, there seems to be a square or rectangle command, and there is. Actually, if you left-click on the Create drop-down menu, it will show you a whole bunch of different commands for creating common 2D shapes, such as rectangles, circles, and polygons, and a whole bunch of different ways that we can sketch each one. Such as the circle, where we could specify the center point and a diameter, or specify 3 points we want the circle to cross over. Or the rectangle, where we could specify the rectangle's opposite opposing corners, or its center point and 1 point of the corner. I suggest you get familiar with the different ways you can sketch these different shapes. But to show how much faster it can be for our application, let's choose the 2-point rectangular command. Let's choose the origin as our first point and drag our mouse out. You'll notice that 2 dimensioning boxes appear. You can click where you want the second point to be, or you can directly put in the dimensions if you already know them. In this case, we had 75 millimeters for one of them. Press on Tab to go to the second dimensioning box and input 150 millimeters for the second one, and then press Enter. And there you have it, our fully defined rectangular sketch created in just one command. Amazing. Now we can press on Finish Sketch and extrude it like we did last time with the Extrude command. And there is our 3D solid in a fraction of the time. However, I needed to show you the line command in order to get comfortable with the basics of sketching techniques and typical symbols you may come across during your sketches. Now that we have our 3D solid, let's learn to cut away material to turn this prism into a brick. First, we need to create another sketch. So press on the new sketch button like before, and the origin of the environment appears. However, this time, instead of choosing one of the origin planes, since we have a solid, we can choose one of the solid's faces as the sketching plane. If you hover the mouse over the solid, you can see that the plane is highlighted, and we can click this plane and select it. And as a result, you can see that the environment will turn parallel to the screen like it did last time when we chose the origin plane. Now we will click on the Create drop-down menu and go to the circle and choose the center point and diameter circle command. With this command, we need to first specify the center point of our circle, so let's left-click somewhere on the solid and drag outwards. You can see that the circle starts forming. If you don't know what the dimension of your circle is, you can simply left-click again to create the circle, or you can input the diameter of the circle in the dimensioning box. In this case, I will put 25 millimeters and press enter. You can see that the circle has been created. However, the border of the circle is blue, meaning that the sketch is underdefined. We need to specify the distance of its center point from another feature on our solid in order to fully define the sketch to lock it in place. To do this, let's choose the dimensioning tool like we did before. It's the one that looks like the dimensioning line in the Create section of the toolbar. Let's first choose the center point of our circle, and then select the top edge of the solid and drag towards the left. You can see that the dimensioning line has been formed to specify the circle's center point distance in the y-axis. Left-click to confirm the dimensioning line. And now you can change the location at which you want the circle to be drawn. Side note, dimensioning boxes in Fusion do accept simple mathematical formulas. Therefore, instead of putting the exact magnitude, I could put the width of my brick divided by 2 and press enter. And the sketch will be moved to the center of the brick. Now let's dimension the circle along in the X direction to fully define the sketch. Choose the center point of the circle and the left edge of the solid and drag upwards. Left click to confirm the dimensioning line, and let's input 30 millimeters. Press enter, and as a result you can see that the circle has moved to the location and the boundary of the circle has changed to black, meaning that the sketch is now fully defined. Now this is it for the sketch. We can press on Finish Sketch and cut away this material from the solid. Let's select the Extrude command like we did last time. Let's select the circle sketch as the profile, and let's select the operation as cut. And using the blue arrow on the screen, we can drag the cut through the solid. You should notice that a red volume starts appearing on the screen, giving a preview of the cut command that will be performed. In this case, we can choose the extend type as all in order for the cut command to cut the material through the entire solid. Press on OK, and there you have it. We have learned how to cut away material from a solid. But our solid is not looking like a brick just yet, so let's learn how to use patterns in order to duplicate features evenly. Let's go ahead and press on the Create drop-down menu and find the Patterns tab. Here we can see different types of patterns that we could use. For this pattern, we will use a rectangular pattern, so click on that, and this window will appear here. For object type, if we press on the drop-down menu, we can see a different object that can be turned into patterns such as bodies, faces, features, and components. Since the cut that we made is what we want to duplicate, and this is considered a feature, we will select the object type as feature. For objects, this is where we can select the feature by pressing on the extrude symbol that appears in the navigation tree down below. As you can see, it says one object has been selected, so that is good to go. And then we will click on Axis to ensure that the selection box is blue and the coordinate origin will appear in the environment. And we can select the different colored axes. Since the pattern we want to create will be in the X direction, let's choose the X axis. For distribution, there are two different types we can choose from. Extend, which will duplicate the feature an evenly spaced amount of times over a specified distance, or spacing, where we need to specify the distance we want between the objects. For this pattern, let's choose Extend, and since it is a rectangular pattern, we could extend this pattern in two directions as denoted by axis 1 and axis 2. But we will only make use of one of these since we only want to extend the feature in one direction. For the quantity, I will leave it at 3, and I'll specify the distance to be 87.5 millimeters. This is a distance that I measured in order to have an equal spacing from the edges to the internal hole. And finally, the direction. We can choose either one direction or symmetric, which would space the pattern evenly on both sides of the feature. But for this example, let's choose one direction and press on OK. And there you have it. That is how to use rectangular patterns in order to duplicate features evenly. Now our brick is looking a lot more like a brick. Now that we have created our solid, a quick note on the navigation bar that I mentioned at the beginning of the video. As you can see, the sketch and features that we created appear in a timeline manner. If we take the line and drag it over a feature towards the left, it will suppress that feature. And so now, if we wanted to change the diameters of the holes, we could just double click on the sketch. Fusion re-enters sketch mode. I can double click on the dimensioning box to change it to 15 millimeters, press on Finish Sketch, and drag the line back towards the left. And now this change will cascade through all the preceding features to give our brick with smaller holes in the middle. Very cool. Now with our brick created, I suppose that's going to be it for day 1 of learning Fusion 360 in 7 days. Look out for day 2, where we'll explore different ways of creating solid bodies, such as using the revolve and sweep commands, as well as other sketching commands, such as the spline command, as we will put this all together to design a vase. But that will be it for now. Don't forget to like the video if you guys thought it was helpful, and subscribe for more engineering content.